everybody. It's time for the next lesson for Mr. C's math class. This one is 6C. No, it's not 6C. It's 6D. It's 6D, problem solving. And now, here's Mr. Cousage. Why, thank you very much, Waddle. Okay, now we can go. I got this. Okay, Waddle, we got this now. Just get out of the way. Okay, you sure you don't want me to help you? I can help. No, I got it, Waddle. Just move along. Okay, well, if you need me, I'll be here on the side. All right, Waddle, all right. Just move out of the way. All right. Many word problems deal with right triangles, and that's exactly what we've been working on till now. Now, the right triangles are going to be within a word problem. So it'll be our job to figure out how the right triangle fits in the problem and solve the right triangle. So I have two examples. That I want to show you, and that's it. First example, here it is. The first example is quite easy. It says, a rectangle gate is 3 meters wide and has a 3.5 meter diagonal. How high is the gate? Well, it says rectangle, but we know gates are rectangles, so we have to make a drawing. It doesn't have to look like a gate, it has to look like a rectangle. So it's our job to draw it. So here is my drawing of the diagram that they're talking about. Okay, so as you can see, it's 3 meters wide and the diagonal is 3.5 meters. So the question is, how high is the gate? Well, that would be this, the x. That's an x there. So now we solve it. You're supposed to realize, oh yeah, this is just a simple right triangle problem. Missing a side, missing a leg, to be precise. So we use our Pythagorean theorem, plug in the numbers, and keep going. Right? X squared, 3 squared is 9, 3.5 is 12.25. Minus 9 from both sides, etc., etc. X squared is equal to 3.25. We need x, so we square root, and we get x equals 1.8. As in all word problems, remember to answer the question. In other words, the answer should fit the question. There was no x in the word problem. The word problem did not ask to find x, right? The word problem asked about the gate. So we have to say the answer is the gate is 1.8 meters high. Okay? In this example, we had to make our own diagram. Some examples, like the next one, come with their own diagram. Here is the second and final example. Right? Bob believes corner A of the tennis court is not a right angle. Okay, so that's a picture of a tennis court on the right there. And he believes that the corner, well, that's my drawing, so it's freehanded. He believes that the corner is not a perfect right angle. And it has to be, obviously, but he thinks it's not. So what he does is he measures. From A to B comes out to 372. From A to C comes out to 264. And from B to C comes out to 456. So is he right? He says that it's not a right angle. Is he right? Well, again, you're supposed to see a right triangle problem. Except here, we have all three sides, and we would like to know if angle A is a right angle. Well, if it's a right angle, then this would be a right triangle. And if it's a right triangle, then this would be true. AB squared plus AC squared is equal to BC squared. Those are the sides of the triangle. we want to answer the question, yes or no, is it a right triangle? So we plug in the numbers. There you go. Use a calculator, get the answers. So is 13.8 plus 7.0 equal to 20.8? Yes, it is. Yes. Yes, it is a right triangle. But wait, that wasn't the question. The question was, is he right? Is Bob right? And the answer to that question is, Bob is wrong. He thinks that it's not a right angle, but it's wrong. That's all. So tomorrow, when we get to the assignment, it'll just be a bunch of different word problems, and you'll have to either draw your own diagram, or some of them will come with their own diagram. But they'll all involve the right triangles. And by now, we're supposed to be experts at right triangles. All right. See you tomorrow. Thanks.